Hello, my fellow YouTubers. This is Roy back again. Interesting little experiments I was just doing for the last 2 hours, and I gotta share them. This is cool experiments. You guys ready? Thought a few more people would get on, but we'll just get right to it. Rock and roll this thing. All right, so I got two little batteries inside. And tonight's experiment is we're gonna walk around. We're gonna check to see if I touch two sections to make like one little mini PMH and spin the wheel, and we're gonna see if it influences the voltmeter. There, now you can't see it from down there, but we'll get in a place where you can. So that's 6.6 volts. We're in DC. I got it for 200 volts. I know you can see me right there. Hi, everybody. Different experiments. So what I wanted to do today was, just got home from work. I wanted to check if I put 12 or 24 volts into this, if it makes more power over here. Okay. The other thing is, can I hold a magnet outside here that repels the magnet in front of it? And if I touch certain things, can I have that magnet turn, right? So we're going to do that experiment as well. And we're going to see if we hook it up individually, well, as a pair, or to the whole thing, and walk around the wheel and try different experiments. All right, so you guys ready? Let's rock this thing. So we're gonna look at the compass. I'm gonna make sure I can do this with one hand too. So you got north here, south pole. So we're gonna go to the two that I tapped. Now this is one as well. So that's the north pole, that's the south pole. Okay. We'll just set that right now. Just put it to the side. So we said that was north, south, and north. So that's the north over here. So let's go ahead and hook up 23 volts, 22 volts. We got those together in parallel. So the positive goes to the negative, negative comes out as a negative, positive comes out as a positive. So a couple things we got to work on. And the main thing is, why is these magnets here? I'm touching one tap right there, right? Watch this. Nothing. Nothing, right? Now if I tap here, we get that to be charged. So let's go ahead and check this and see how strong it is. All right, so who do I got out there? Anybody that I know? Anybody that's familiar? Let's see. You think we can hold up this van? Oh my God, this thing is heavy. Think we can hold this up? We're talking about two little batteries. These are what, fire alarm batteries. And I'm using this thin ass wire, and we're going to go into these two, and we're going to see if we can get this son of a bitch to stick. So I need two hands to do this. So let's go ahead and try this experiment. So we're going to see by adding voltage on the inside, about 22 volts. I guess I'll have to take the voltmeter in a second, try. No, I don't want to move it right now. So let's, can you guys see that? Yeah, sure can. Who's out there? What's up, Tommy in the house? So we're going to try to see if we can stick this by the two batteries that are on the inside. And it pulls it from me, I'll tell you that, okay? Yeah. How you like me now? All right, so anyway, so we got this sticking just from those two little fire alarm batteries. They're 12 volts each, both sitting about 12.5 volts. They're not fully charged, and they're holding on. And think about the resistance in this wire right now. It's not even getting hot. Oh, it's a little warm, but it's not getting hot. Two of these pieces holding that ass heavy metal up. So at least we show we're getting one thing, guys. What? Leave your comment. What's going on, William? How you doing, my buds? So you look at the magnetic strength that I just created here in these two, and they're coming. And trust me, if this was connected to a 12 volt like car battery, these would have melted away already. So that means there's something else going on there. Something to do with, I mean, I don't know. I can't explain it, to tell you the truth, because these wires are thin, very thin. And we got about 12.5, 12.75 volts on that battery. About 12.75 volts on that battery, and I got these in parallel, so the positive and the negative coming out of those, and we're tapping in these two, and we're holding up that nice. I mean, I'll tell you, this son of a bitch is heavy, 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 heavy. All right, and they're not heating up. But they are dropping bars. Let's pick that up again. So, you see that spark, right? Oh, strong though. It's strong. It's strong right now without it. Jeez. That's hell. It's crazy strong. Like the magnets are stronger now. But let's go ahead and tap that. Get that to stick. All right. So I guess the important things here I'm trying to show is that these these B magnets here with resistance wire, not resistance wire, just regular wire, not melting the wire. This wire would melt. I don't understand why it's not melting and why I got 22 volts coming in and these two here are acting like all right. That was study number one. All right. Study number one. The second one is kind of even cooler than the first one. The first one, nothing's hot. See, the other day when I did this with the car battery, these got a little warm. Nothing's getting warm now, but for somehow these. For this to hold that, trust me, something special is happening right here. This is crazy above and beyond that I see with this wheel for the last 7 years. Not like I ever had it set up like this, but for that to do it and this to still be cool, and I got 22 volts coming in, this should have melted. That should have drawn enough amperage. So it didn't draw a lot of amps. But it left a lot of magnetism. Leave your comments, guys. I want your feedback. You know what I mean? This is what this is all about. All right. So the next one we're going to go ahead and go into is this. We're going to charge the whole wheel. Okay. So I got tape on here. Can you guys see that tape? No, can you? No, my hand's up there. So, see that? Got tape on there. That should be the positive coming in. So here's the positive. All right, taped off. And here's the negative. Can you see that, guys? Can you see them getting sparks? There's a lot of resistance in there. 5 ohms, but you think that would be... All right, so now we're getting better spots. So now she's starting to activate, all right? So before I do this experiment, understand one thing. I want to pulse this. We're not pulsing it right now. We're just landlocking this son of a bitch. And what we're doing is just having it on. It's really defeating the purpose of what I want to show you. But I haven't got far enough yet to start pulsing this. When this is pulsed, it's a different ball game. And we'll work through that and see what the different ball game is. But I already know that it's where you have to be. Couple key things that I have is, you guys ever heard of them? They're pulse resistors. And I got some pulse resistors. They're great. They're great. We'll get into that at another time, but we could show how we can add resistance, but it's only from the reactance. You guys get me with that? I'm trying to talk about reactance in a way to where when you take a bunch of things and you put it together, and it's like making it's a recipe for a soup, and you put it all together, then the reactance of it, obviously it tastes delicious, that's a reactance on the soup. But with this, it wouldn't be, it tastes good, it would be the fact that how it's reacting. You already see one thing. That's number one. The first test was that 2 of these magnets in groups of 4, 2, 4, 5, groups of 5, was able to not draw enough amperage, but still with 66 turns on each one, 16 gauge magnetic wire, 2 of them together would be double that, so it'd be 112. And the resistance of it is individually, if it's 5 ohms for 24 spikes, you guys do the math, you can see what the resistance is of each one. So let's move on to the second one. So make sure you guys are leaving your comments. So we're going to go on now. We're going to fire up the whole freaking enchilada. I'm going to pull the phone off, and we're going to go ahead and come over to the voltmeter, and we're going to look at lights lighting up, and we're going to see, I guess on this experiment is this. When I fire up the inside, do I get more power coming through? The PMH is coming in. Well, we're going to see. So 5.7 volts stored. All right, so capacitor, it's not dumping out. Here's the reed switch it's running up. So let's dump the capacitor. So what I'm going to do is move the reed switch so it's on, and it should dump out at some point. I can't even get it to dump any further than it's at. So it's still holding 3 volts, 3.5 volts in that capacitor. Just as here I am, I'm one side, you're the other side, and there's a differential, right? So here you are, 3.6 volts. We're going to go ahead and suck this thing up here. You can see we're going to have some spark. So we'll check it. I'm just guessing 22 volts, 23 volts. It's 2 12-volt batteries, but they're not 100% charged. All right, so we're going to go ahead and spin the wheel. You can see lights coming on, and I'm going slow. So I'm really just moving slow. Lights already coming on. Volts came up to 7.6, so we came up a volt. Light went out. Look, the wheel slowed down. So let's just look at, I don't want to kill the wheel. So the wheel's moving slow. So that tells me right there that there's more magnetism going on. So the light is on, and we're at 7, almost, we're at 8 volts. All right, so now the light's bright. Okay, I'm not even moving that fast. So I'm going to go ahead and invest in an RPM gauge that stays on. I can just have a gauge like this voltmeter and just look at it without a handheld. I don't want a handheld. So that's 8.5 volts. We're doing good. So basically, yeah, you got it, right? So now we got the lights on. This son of a bitch is full bright right now. I'm not even going fast, right? What's up, Mike? Hello. Welcome to my channel. But right now we got 8.5 volts, and we're just moving slow. We got the light on. This is pulling 4.5 watts. Right now we got it ticking off a reed switch. And we're trying to just do, hello, William. William's got some conversation going on out there. Pull camera back from magnetic field. Really? Is something going on that I don't know about? Look at that thing move. All right, so let's go ahead. We got 5.5 volts. Uh-oh. We got to run away. Lights are out. Let's stop this. Oh, shit. Thing's heavy. All right, so the magnetic field is screwing stuff up. Oh, yes. All right. Major interference. All right. Well, all right, so let's go back to that study. Look, I'm turning this off right now. So I got another one study that I did that was freaking blew my mind. You ready for this, guys? All right, Tommy. Listen, you're going to like this one. I kind of had to bounce off of that one because people are saying something about interference. So let's go with this one. So I got this thing as a table, okay? And then I have this neodymium strong ass magnet, okay? You can see how thick it is. What we're going to do here, just based on what you said is interference, we're going to show when we plug this in and put it on, what this magnet does at a distance. And this is really a good experiment. You know why? Because it shows me the wheel becomes like alive, where it gets stronger as it builds out. So right now, we're going to take the neodymium magnet without me holding it. So what we're going to do is we're going to get this. Let me check. You guys see that? I got to walk away from everything. I'll tell you what happens a lot. This is kind of a thing that I go through. I have a bunch of these compasses. I just bought a boatload more too, and I'm talking 6, 7, 8 of them I have. Why? Because all this ruins the compass. But I'm always dealing with, I never trust a compass if it's true north. So this one right here is like, where my thumb is south. And you see the compass is facing that way. So I'm gonna go walk off, take this compass and check it and away from the magnets. And I guess let's just do that together, right? Why not? Let's walk off, and we're going to come over here and face in the direction that I know this camera's facing should be north. Guess what? The magnet is backwards. See that? Throwing my magnet again. So I constantly have to take, what you do is you take the, you guys see that. So I want, that's the north. That's the south facing the north, right? So what I'll do is to rechange this compass. I'll face north, okay, towards it. And I'll take it and swipe it across the top one time. Now look at that compass now. Listen, I just realign the compass. Now the compass is facing true north. I constantly have to go through. Look at the compass. So that direction there. Let me get the strong magnet out of my hand. But I think it's so strong it's influencing everything. So I'll put it back where I got it. But anyway, let's go back to this. So look, you can see, yeah, there was a magnet influence. So there you go. So we're at north now. I readjusted the compass. I deal with this a lot. But it's part of experimenting, you know what I mean? So now I can tell which one's really north or south. I have to always double check all the time, because even when I fire these up, they get so strong. What's going on, Mike, in the house? I got a bunch of new peeps showing up, man. I love this. So I hope you guys enjoy it, man. Listen, I know nothing. So don't expect me to be acting like I'm an engineer here. All I am is a guy that's interested in Leedskalnin's wheel, built the son of a bitch, and right now Ed's dead and I have the wheel. So whatever he did with it, we'll try to figure out. But right now we're trying to figure the wheel out. And right now it's a stator. That's the inside of like one of Tesla's induction motors. All right, so back to my compass. So now I got it to where it's right. So I can get this magnet here. Let me make sure you guys see that. So right now I'm holding up. This will be south to north. That'll be north to south. Okay, so we're going to flip it. So opposites attract. So right now, that right there is telling me that. Well, actually. Can you guys see that? Can you see it? Yeah. All right, so in front of me, we're going to set up where we have the taps. 2 taps are right here. 1 tap is the north, and that's the North Pole tap, and that's the South Pole tap. 24 taps all the way around this. I'm calling these little bevels taps. All right, I got 2 connections. This is 1 wire wound opposite directions per. So when you want the front of the core facing you, the pole of whatever you want it to be, you'll wind that coil in the direction of what the pole is facing you. So for instance, if this pole right now is north, which is what it's saying, I would take this and wind it clockwise. And then if this one's south, which it is, I would come over and wind it counterclockwise. It's amazing to me that you can just take a negative coming in and a positive coming in. All right? Now hear me out, guys. A positive and a negative coming in. And all of a sudden, in the 1 wire, all the way around, it's going to, because it has an iron core, I haven't checked it if it didn't have an iron core, but I could pretty much say, I know for a fact, without even checking that fact, that whichever way you wind it, without the core anyway, the spin is going to make a pole towards that direction. So I got to check that. I'm going to do that. I'm going to experiment with that tomorrow. That's another experiment, just to verify, check my own facts, right? Because anyway, so it's 1 wire, and the fact that it's all going in here because of the copper, its direction is allowing that spin, that rotation, to come out as a guaranteed projected pole based on what spin you do. I think that's phenomenal. So let's go ahead and we're going to check. So over here, we're back on our 2 taps. Got our north here, you got our south. So now I'm going to take this nice strong neodymium, and that right there is a north facing, okay? So we're going to come over here. That's the south. So that's the south, and then that's the north. So what I'm going to do right now is take this little thing and make it as a table. So we're going to have north facing north. And I guess the way I can do this now is I can grab the phone up, and I got this set up. So right now, the front of my thumb, that area right there's the north, facing out. South is back, and we know that that is the north on this side, the right side. There's a left tap and the right tap. Left is south, this is north. So we're going to approach it, and you can see that it'll stay, right? The magnet stays. You can see the position. Now I'm going to do is connect the wire. All right, you can see it's going to be sparking, right? See the spark? So we're connecting that wire, making that stronger. Now we're going to take the same setup. We go over to the right pole, and we're going to get closer and see if the magnet decides to. It's not moving. It just didn't. So let me verify something with my own hands. See, that's pulling, that's pushing away. All right, so you can see the magnet. You can see the magnet in that area there, having a stronger field on the outside versus if I unplug it. So it's unplugged right now. And then we're going to do the same thing. There's good morning, Ender. So you could see that it's reacting to the magnets, and this is on its own strength, right? This is just I'm surprised the neodymium doesn't flip around and just attract itself. And you can see it moving right now, and it's reacting, but it's not flipping itself, because usually they flip. Look, it's moving closer. That's the magnets, right? Without adding juice on the inside. So now we're going to go back and we'll add power again. We'll bring that up closer. All right, so now it's definitely stronger. You see it's snapping now. So now it's, I'm out there just, you see it moving. So the field got stronger coming from the V magnets from having it charged on the inside. So let's go through this experiment now. So here we are, back to this. We're sitting with 9 volts. Let's bring, we have all the coils all the coils in the center here on the stator are activated right now. We got about 22 volts coming in. Got 5.9 volts. Let's go ahead and move the wheel. And let's see, lights lighten up, so we're burning energy here. Let me pull this away, which is the reed switch dumping the capacitor. So right now we're at 12 volts. I'm not even moving the damn thing. You can see it. So now I'm going to move the wheel. And we are batteries on in the inside, right? So I can tell you right now my volts are up. So right now I got the wheel moving, nice, good speed. With the batteries on the inside, I've got 38 volts up. I'm dropping faintly. Let's go ahead and start dumping it. I just heard a big snap over here, and right now I got this away. The light's still on. We got it off now. All right. So obviously a reed switch is not for relay. All right. So I get this, but you know what? This is what it's all about. For the ones that don't know, they just learned. So I'll just give it that. Lesson learned. Reed switch So, reed switch should not be used for a relay. So we're still sitting on 8 volts. Power's still on the inside. And this is where I think the volt is. So let's go ahead and switch it out now from being all charged up. Let's go ahead and charge up just these right here as V magnets. So if I remember correctly, this is the negative and this is the positive. We're going to check that. Doing a lot of stuff here and hate to go backwards. So my compass disappeared. Here it is. So we got south, north. Let's go ahead and juice up this right here. Huh. Let's try that again. Let's see if it's anything. Nothing on the magnets. Magnets dampening everything. No electric coming through the magnets. Got some action there, right? So let's go ahead and fire those son of a bitches up. Make sure we still got. Oh shit! I got them backwards. So that's north, south, north, south, north, south. Let's check and see if it's backwards. It won't hold up this big old PMH if it's backwards. It's right. It's holding up, that big old guy. There's some power coming out of that. All right, let's drop it off. Goodbye, PMH. All right, so now we're going to spin this, and we're going to check the voltmeter. So right now we're still sitting at 28 volts. That capacitor is holding 28 volts. Should have dumped that a while ago. So let's go ahead and watch this. We'll bring the reed switch close. You'll see the light come on. See the light coming on? So the light's stuck on right now because the volt's so high. Light's on. This guy. There we go. But we're going to dump it. So let's just bring it in. We're dumping, we're dumping, we're dumping. What's going on, Keith? My plan with the wheel for right now is to get it turning, whether I'm using a battery or I'm having it turn on its own based on its own storage. So right now, on its own storage, without using a battery, I want to have the wheel turning. I want to learn enough to build up enough storage and then dumpage. And what I'm already learning here is what we're seeing right now is this capacitor is off the reed switch. So every time the capacitor dumps, I can put it somewhere. So I'm going to put it to a PMH that's designed to the capacitor. So they're kind of having a good balance of frequency. No, I wouldn't even say frequency, but just a good resistance built up. So it's sort of like the experiment I just showed you guys, where I didn't burn the wire and I held up that heavy bar. So I built up a lot of magnetism based on 2. Somehow I think they're all helping out, but basically because you're tapping these 2, it's focusing and concentrating on the iron. So I'm showing that somehow resistance, or I don't know what you would say, but it's appearing. I think that can happen here, and this wheel could turn based on its own power it's making. Then I can add other coils. We're not dealing with Lenz's law in a sense here because these aren't pulling from this side, but experiments will kind of show us if that's true or false, because once I get the wheel turning, we have a couple things established. One is that we have power in to turn it. 2 is we'll determine, I'll make it variable but frequency. So frequency, power and frequency, and then we'll determine what we're pulling out of it. We'll have some good barriers to make this kind of everybody's little toy, because of that's what it's all about. You know, and you can say all day free energy, but I'm not saying that. I'm just saying that this is something different that's out there that I don't see out there, that it's bare bones. It's stuff that's to the waistline. Everybody's educated about it, just, you know, kind of moved on with their life, and some stuff don't matter anymore. And here I am, fresh, 7 years now, no knowledge of this stuff. And I've been just fascinated. So reed switch, no. Let's see what we get out of just firing up the two. So you can see sparks. Even the wheel kind of has a good little turn about itself too. The amazing thing is this. Another thing I want you guys. Hey Jay-Z, man, I love your Tesla thing there. So the thing is this that amazes me. So we got this fired up right now. It's about 22 volts, maybe 20. It's dampening down. Who knows? I'll have to check it later. But now these here, we have iron to iron reaction. And every time that goes by, because these are not fired up, and I have a capacitor not dumping back into here or there, these are in series. So I got one going into the other, coming out of the other, coming into a multiplier here, just two capacitors, two diodes to step up the voltage a little bit, send it to the capacitor, DC capacitor, then come out of that into a reed switch, which is dumping the capacitor. It's all it's really doing, but it's taking a big hit. I'm learning now how to increase the voltage based on what I'm doing, and now the reed switch is saying, hey, wait a minute, that's not what I signed up for. So it's kind of rebelling on me, but it's okay, because I know better than to use a reed switch, but I just wanted to get away with it as long as I can. So you got these coils here, which don't have power coming back at them, so they're only reacting off of what's going on over here. So now we're going to look at the voltmeter. We're at 5.2. And now we're going to look and see there's Superman strength. We know that's coming up now. Now let's just look and see if the voltmeter is going to react any different. No, I don't see it. I don't see any lights going on. Do I have it hooked up? Yep. Everything's good? Yep. So we're now moving slow. I got 8 volts built up, so that's what it kind of needs to run a 4.5 watt LED. This is turning. Oh, that's right. That's on. So now that's off. I didn't want that on. So that was putting a load on. So now let's go ahead and turn. And let's see if we can get more volts out of it. If it gets up in the 40s, then I'm going to say that little one section, that one little section didn't make a difference. It's up to 32, 33. Let's bring in this guy's going to go nuts. Yeah, that thing just snapped. So it's stuck on. Look, it's over to the side. See the lights on? I got it off there. All right, so next video I won't have that resistor hooked up to the capacitor. Well, I guess I will, but I'm going to put a dioid in there, and because I think it's maybe this. Yeah, I don't know. I don't think it's the snapback that's doing it. It's just a lot of voltage coming out. I'll have to get a magnetic relay. I think a magnetic relay will handle it better. So that'll enable us to release the capacitor. Then the capacitor is going to act like a tank circuit and it's going to be the capacitor to the inductance of what I have in front here. So let me get these unplugged right now because it's still on. You can see that it's still on because I could probably still. Nope. Got it no more. So you can see now work from the inside of the wheel. We're making reactions magnetically on the outside. You can see in my hand that this thing is moving to the different poles. So I guess what that's showing me right now that I'm going to build my own. Oh crap! Oh crap! I'm going to build my own magnetic switches. That's the thing to do. Let's build my own magnetic switch. Warning! Warning! Will Robinson. When things go awry, that wasn't that bad. Everything's cockeyed, but I guess we've seen pretty good examples. But so what was I saying? So yeah, my own magnetic relay, because all I have to do is take the neodymium or any small magnet. When this comes up, it'll push away, so it'll activate a PMH that is taking the load from here. Oh, that's another good experiment. Let's do that. Let's take the load out of the LED now, and let's dump it into let's dump it into that guy. So that means this. That means we're going to be lessening the voltage because I'm going to disconnect one to the other because they're in series. Remember I told you that? So I do that because it steps up everything. So now I'm going to disconnect that. And now we're going to have only this guy right now is working the system. So let me straighten this out. And let's check and see what one is doing. I may or may not. Let me see. Make sure all this is still workable. I think it is. All right, so we're still moving. All right, so now we have no power on the inside, and we're just using this PMH. That was not hooked up to anything. There's an LED running over here, 4.5 watts, pulling off a DC capacitor, and right now, without anything as a load, we're going to go ahead and turn this. All right, so nothing's coming in. So that means whatever I did, I kind of have it not working. And I don't want to get into all this right now. I don't know where to. So we got AC coming out into here. I see it moving now. Maybe I touched something. No, that's not moving enough. Anyway, yeah. So you got the gist of everything we talked about tonight. The experiments, just with one PMH, we can come out. We can get half the voltage. So if I was getting 32 volts, you see, I'd be getting 16, 17, 18 volts. I think stepping up the voltage is very important. I'm already stepping it up with the multiplier one time. I could get into 2 times, 3 times, or 4 times. But I don't know. I would think that somewhere you're going to lose. I think you're going to lose it at the current. But I'm also seeing when the capacitor dumps, and it dumps every other turn, that the voltage stays up to about 22 when it was at 35. When I put the load on, when the load goes off, every other magnet, it stays to about 22 volts, and the voltage stays up. And the capacitor has more of a fill about itself. It can handle more of a load, and that's what I'm learning right now. And I hope you guys are learning as well. If you don't, unless you already know it, you're looking at me like a fool, but that's fine. I don't care how you look at me. I don't even care what you say. I do appreciate all of us learning together. So whatever you do, leave your comments. I do look at them as good help. Anyway, so I can already see from what the experiments I'm doing and showing you guys is that I'm able to keep more storage in the capacitor. Now that capacitor there is not the one I want to use, even though it's 6,000 microfarads. I'm showing good results with it, but I need a capacitor that's going to hold like the abundance, right? And then from there, it would trickle out and go to another capacitor that would be matched up to the coil that it's going to dump into, which would be the driver. So I don't think it's either one of these guys, because maybe it's not the right wire, maybe it's too many turns. I still have to get into all that with the induction and the resistance and what we're actually able to produce. So right now it's more about learning what we're going to produce, how I'm producing it. You know, I'm turning the wheel by hand right now. I can't have it trickle on its own, but I have to charge up the capacitor enough to where it gets it going. And then once you get the capacitor charged up, then it gets it going. It goes real slow, and it's really not building up. It's just fighting itself. So, which is cool in itself, because it shows me that I have potential to get it to turn more. But right now, I'm still trying to learn how to take what I have and one, amplify it. Two is to store it. And then I think the main thing is to condense it. So that's like the number one I just mentioned. That needs to come out of the wheel turn and it condenses. It condenses and builds a major big pressure. That big pressure needs to be not tapped in the way to where it dumps. It needs to be tapped in a way where it's a loose coupling. One thing I did learn from a good experiment was with this big old capacitor that I used for my Van de Graaff machine. When you would come up close to this, you would hear the hissing because of the electrostatic coming into the pickup. And from there, it was going on all busy. It was busy downtown, but it wasn't connected, because if you connected it, it would be a snap, bam, a quick release. So what I'm getting at is there needs to be a pressure capacitor. I need to figure out what that capacitor is. Leave your comments. And it's something that's a pressure build, but it's a loose coupling to where it allows a trickle out. And I think that's how the sort of the universe works, but we'll get into that to another day. Guys, leave your comments. Hopefully you enjoyed the wheel. The wheel is cool. I mean, just the fact, like right now, I just disconnected something. I don't know what the hell I did, but when I came home today, I just turned the wheel and got it up to like, I don't know, 42 volts. And then I left, went to work, and then came home again. It was about maybe 8 volts still left in there. So it held. And I thought maybe I put a diode in there and stop it from coming out, which is right, a cool thing. But and then I turned the wheel and it just all fired back up. I'm just kind of like cool, like little gel with it, because it's cool shit. It's cool stuff. It's totally different from whatever I did from the last 7 years. Now it's a whole different ball game. So it's exciting. All right, so you guys have a great night. Leave your comments, good, bad, anything you want to throw in there, because I read them all. All right, Tommy, the door magnet. Well, I mean, that's what I was saying. Something that's Even light sensors. This is another. I missed half of that, so I will check all the comments. You guys, peace out. That's my boys, Smokey and Tommy. I know Tommy leaves a lot of cool stuff. Tommy, you keep rolling, man. All right, guys. To my minion over there, he's watching. That's Ed Leedskalnin design he's hiding. Eli, old school, variable capacitor. For sure. You know what I mean? I mean, you can see the little experiments and things I'm learning. This is moving along pretty good. All right. Peace out, my bro hands. Peace out, my bro hams. Love y'all. Y'all be safe.